Hey everybody, here's a potential solution to problem 8.9.20 from Collaborative Statistics. Looks like we got a Time magazine poll where they asked 1,000 adult Americans what is the main problem facing the country. 1 in 5 answered crime. So of the 1,000, 200 of them answered that crime was the problem. Okay? Interesting to know how they asked that. Was it an open-ended question where they filled it in? Was it a list of potential choices they selected from? I don't know. That's all the information I have, same as you. Interesting to think about though. If they were given a choice, how would that affect this right here? Right? If they were given a choice of say 5 things and crime was the 20% response, would that be more impressive than if it was an open-ended response and crime was a 20% response? Me personally, if it was an open-ended response and crime got 20%, I'd feel much more strongly about that than if it was just a choice of 5. Because suppose the choice of 5 was limited to just 5 and there are 15 others that I thought were important but weren't on the list. So, something to think about when you're out there collecting your own data. What is the population proportion of adult Americans? Sample proportion is 20%. What's the population proportion? Random variables X and P hat. Well, X would be the number of folks in the sample that said crime is the most important. Clearly values from 0 up to 1,000. And that's what the definition of X would be. P hat, I'm going to call it P hat because I like I like using the phrases that everybody else uses. P hat, or 20%, is going to be the sample proportion. But you and I both know that we cannot say 20% of Americans think that crime is the greatest problem because our sample has error built into it. And that's what part C is all about, is constructing the interval, which I've done over here, using one prop Z int. The interval is 17.5% up to 22.5%, which looks like this on a scale. So the best you can say, it doesn't say to interpret it, but you know what? Let's interpret it. I'm 95% confident that at least 17.5% and at most 22.5% of Americans think crime is the overriding problem. That means I can safely say with 95% confidence it's less than a quarter, it's greater than 1 in 10, but I cannot distinguish a difference between, say, 19 and 21%, which are both contained in the interval. Anything in the interval is indistinguishable from anything else in the interval. Things outside the interval are statistically significant. Error bound. The error bound would be the distance from the center of point 2 out. Looks like it's about 2.5% of an error bound. Suppose we want to lower the sampling error. Okay, lower the sampling error. The error is governed by that error bound. What is one way to accomplish that? Well, I can think of like half a dozen. There's some lame ones and there's some good ones. The lame one would be to lower the confidence. I mean, drop your confidence to 68%, then you only got 1 standard deviation, right? You'd essentially come in half as much, or you go out half as far as you have. That's totally lame though. Nobody reports anything at 68% confidence. So what's a better way to lower that sampling error? Yep, that's always the best way. Raise your sample size. That's the best way. It's the best way because then you guaranteed will lower your sampling error, you'll shrink your margin of error. What might not happen though is it might not be centered at point 2 anymore. Okay? It might be centered elsewhere. And the interesting thing about that is, mathematically, if you think about, well, think about this. Your standard error, the book is referring to, for a binomial random variable, looks like that. Okay? So as this goes up, clearly the whole thing goes down. Hence, raising your sample size, lower standard error. If this changes though, it's going to change your standard error too. If you remember our discussion from before, the closer p hat is to 0.5, the larger this standard error is. 0.5 and 0.5 here make the largest possible standard error. The further they get from 0.5, the smaller their product gets. So let's suppose that you keep the sample size exactly the same but resurvey 1,000 people, and p hat now comes in at 0.1 versus 0.2. Well, that means this numerator went from 0.16 to 0.09. Does that make sense? And because of that, you're going to change your standard error just by virtue of the different responses in the poll. So it's a neat little interplay of what actually goes on with the mathematics behind the scenes. So keep that in the back of your minds. The sampling error is given by Yankelovich partners as plus or minus 3%. In 1 to 3 complete sentences, explain what plus or minus 3% represents. I called it 2.5%. They're calling it 3%, probably a little CYA move. What it means to me is that, this is going to be kind of wordy, but they want 1 to 3 complete sentences. First sentence, most important. Our sample is just that. It's a sample from the population, number 1. Number 2, our sample is not a perfect representation of the population, most likely. Number 3, that means that the sample proportion p hat that we have gotten from our sample is not exactly equal to little p, which is the population proportion. And I'm going to give you 4 sentences. Therefore, we have to put a margin of error on our p hat to make sure, with a set level of confidence, the value we're actually looking for is between the ends of our confidence interval. So that was 4 sentences, but I think that's a pretty good explanation. The 3% or 2.5% represents the endpoints of that error bound. Cool. All right.